Alright, section 4.6 of Triola's book is about counting. So the first rule in counting is called the multiplication rule or the counting rule. By some multiplication, by others counting. I like to just refer to it as the counting rule, and what we're trying to count is the total number of outcomes in two or more events that are occurring simultaneously. So what we're counting is these number of outcomes based upon the number of ways that each event can occur. And you can think of M and N in this case in terms of the simple events. So the total number of outcomes is the product of the number of simple events. So let's take a look at our example of tossing our coins. Now we know from drawing the tree diagram that there are 8 possibilities. So what we're going to do is we're going to say, okay, how many ways can the first coin be flipped? What are the total number of outcomes on that coin? So we'll call that M. And the total number of outcomes for that first one, M, is going to be 2. And then for our second coin, how many is the total number of outcomes on that second coin? Well, that we're going to call N, and that would also be 2. 2 simple events, a heads or a tail. And then our third coin, what's the number of outcomes for that one? And we'll call this one O, and there are 2 for that one as well. So the total number of outcomes, total, and then number of outcomes is going to be the product of the number of ways that the first coin can turn up times the number of ways the second coin can turn up times the number of ways the third coin can turn up, which is going to give us 2 times 2 times 2, which agrees with what we saw as being 8 possible outcomes. And that was the way that I had found out that, oh yeah, we have to have 8 possible outcomes on this to make sure that I had all of the right possible outcomes. So it's good to know how to count these in a different way than just drawing a tree diagram. Now our next example here says how many 4-digit codes are possible from the digits 0 to 9. So the first digit in the 4-digit code is what we're going to look at. And then the second digit in the 4-digit code is what we're going to look at next. And then the third digit, and then finally our 4th digit. Now the only thing that can be a little bit tricky in doing this counting here is that between 0 and 9 there are not 9 digits, there are actually 10 digits, right? Count them out on your fingers, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, that's 10 of them. So there are 10 possible outcomes for the first one, 10 possible for the second one, 10 possible for the third one, and 10 possible for the fourth one. So our total number of outcomes here will be 10 times 10 times 10 times 10. And another way of saying that, of course, is 10 to the 4th power. And so 10 to the 4th power, we know, is 1, 0, 0, 0, 0, or 10,000 possible outcomes. I don't know about you, but I sure wouldn't want to have to draw that one out in a tree diagram. That would be pretty crazy. All right, now let's take a look at this one. From the 4 weeks in a month that I teach my algebra class, I wish to choose the possible outcomes for my quizzes. Each week I teach algebra on Monday through Thursday. So Monday, Tuesday, Wednesday, and Thursday. In the 4 weeks, how many possible outcomes are there for the ways to give my tests, or my quizzes, essentially? So in the first week, I could give my quiz on a Monday, a Tuesday, a Wednesday, or a Thursday. That's 4 possible outcomes. In the second week, I could give them on Monday or Tuesday or Wednesday or Thursday, and that would be 4 possible outcomes. And in my third week, I could give those quizzes on Monday or Tuesday or Wednesday or Thursday, and that would be 4 as well. And on the 4th week of the month, I could also give the quizzes on Monday or Tuesday or Wednesday or Thursday. And so my total number of outcomes here ends up being 4 times 4 times 4 times 4, or 4, 2, the fourth power, which ends up giving me 256. So 16 times 16, in other words. So those would be my total number of outcomes and the total number of ways. And again, I don't think I'd want to draw that in a tree diagram. I could, but I don't think I'd want to. That's a lot of ones to draw out and just take a lot of time and space. So now I want you guys to see how many possible ways are there of doing event A and event B, where event A is rolling a 1, 2, 3, 4 on the first roll of a die, and event B is rolling a 5 or 6 on the second roll. So go ahead and pause the video and then come back and see if you got the right answer. All right, so if we look at this problem here, on event A has 4 possible ways that it can happen, and event B has 2 possible ways that it could happen, and therefore the total number of ways that we would expect this to happen would be equal to 4 times 2, or 8 possible ways. Why don't we just go ahead and check that out? So if we had a 1 on the first, we could have a 5 on the second, right? If we had a 1 on the first, we could have a 6 on the second. If we had a 2 on the first, we could have a 5 on the second. If we had a 2 on the first, we could have a 6 on the second. If we had a 3 on the first, we could have a 5 on the second. If we had a 3 on the first, we could have a 6 on the second. If we had a 4 on the first, we could have a 5 on the second. If we had a 4 on the first, we could have a 6 on the second. And let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Absolutely, that's exactly what our counting theory said. And so hopefully you're starting to see why it's nice to be able to count these as well as to come up with them in a visual means as well. It helps you to see what the rule is telling us by being able to visualize it. It's helping us not to have to visualize it to necessarily know a total number of outcomes. Now the next thing that we want to talk about is a factorial rule. Now the factorial rule is based upon arrangements or sequences of n things in a particular order. Now the factorial rule can actually come from the basis of the counting theory, when we say, okay, once we've used something, then it's gone and we don't have it to choose from. So this is like the idea of sampling without replacement. And again, this is just the event 1 has all these chances, and then event B, the second event, has one less chance, and then the next event has one less chance than the one before, and so on and so forth. And that's the idea of factorial. So when you look at factorials, you are actually doing the counting rule. You're just multiplying the number of outcomes, but there's diminishing returns, so to speak, here. So this n with an exclamation mark is read as n factorial. And n factorial starts out with the number of ways for the first one, and then there's one less number of ways for the second one, and then there's 2 less ways for the third event, and so on and so forth, on down to when we have n minus 1. That way we have, that one tells us that we are now down to 1, essentially, where this is equal to just 1. So we have all the way down to 1. And these are what we call arrangements or sequences. So there's an ordering that is taking place that we have to pay attention to, sampling without replacement. Now, something that you should know as well is 0 factorial is always equal to 1. So you know how we have the 0 exponent defined in mathematics? Well, with the factorial, we also have a definition. 0 factorial has to have a definition, because it's not this natural thing. It has to have a definition place to start out. So that is our definition place. So let's take a look at some examples here that would use this. So let's logic this example out to see where the factorial rule comes from. So how many different arrangements are there of the digits 0 through 9? So if I look at the first digit, how many choices do I have of putting numbers in here? Well, I could choose 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, and that means there would be 10. But once I've chosen the first digit, right, so let's say I choose the 9 first. Well, now I only have 0, 1, 2, 3, 4, 5, 6, 7, or 8 to choose from. I only have 9 digits to choose from. And then the next one, well, I've already chosen 9 and 8, so now I only have 0, 1, 2, 3, 4, 5, 6, or 7 to choose from. There are only 8 choices to choose from. And then the next one from there, I've already chosen 9 and 8 and 7, and so now I only have 7 choices. And this continues on down through all of the digits until I get to having only one choice left. I've chosen everything but 0, and 0 is the last one. And so that is factorial. Now we can do this with our with our calculator. We're going to find the ability to do our factorial within our math menu. So if we go to the math menu key on the face of our TI calculator, and then we go to the menu that says PRB, and then we're going to scroll down to the one that has a factorial. And so what we'll start with doing is we'll put in whatever we want. And so in this case, we would start with the number 10 out here. And then we would do all of this stuff here. And then we would hit the enter sign, and we would get what 10 factorial equals. So the 10 factorial, let's see if I can, I'm not really sure that 10 factorial is on there. Oh yeah, there's a factorial key on this one. So 10 and then factorial, oops, 10 and then factorial, and that is equal to, and that's our number right there. So there are 3,628,800 possibilities. So 10 factorial is equal to 628,800, and that is our number of ways that we would be able to arrange the numbers or the digits 0 through 9 in a 9-digit code, essentially. All right, now the next thing that we want to do is we want to look at this problem. So basically what I have here is 4 wires. I have a red wire, a green wire, and a blue wire. And I'm going to attach these to a circuit board. So I have circuit board here, and it has these 4 possible attachments. And I want to attach a green wire, right? And then once I've attached a green wire, you see then I only have 3 places which I could attach the red wire, and then once I've attached the red wire, then I would only have 2 places I could attach the blue wire, and then finally there's only 1 place that I could attach the yellow wire. And you see that idea is very much like the idea of the how many ways can M occur? Well, 4 ways, right? Because there's 4 places I could attach it first, that first wire. And then the second one, well, then there were only 3 left, right? And then the third one, there were only 2 left. And then the fourth one, there was only 1 way left. And so the number of ways we could attach these 4 wires is 4 factorial. 4 times 3 times 2 times 1. And so you see that that's really just the counting rule. And this is 12 times 2, which is 24. And if you do the factorial key on your calculator, you'll see the same thing. So let's clear this out and go 4 factorial. And then what's that equal? There you go, 24, just like we got before. So on our calculator, of course, our scientific calculators, we have a little bit more complication